Imagine paying $100,000 for a single system to move lab results from one system to another. Now multiply that by dozens of departments in a single hospital. This was hospital interoperability in the 1980s. This meant high costs, long timelines, and usually the nurses just walked between different terminals because they couldn't get the systems to work between one another. So this is where our story begins. Around this time, ISO came up with the Open Systems Interconnection, or the OSI model, and it was gaining traction. This model described how data can move between systems through a network. To understand how this works, let's imagine you're sending a letter to a friend. To do this, you need the infrastructure. You need roads, you need postal trucks, post offices. You also actually need to write the message in a language that your friend understands. And then you need to put this inside an envelope, you need to put a stamp, you need to write the address. So this is sort of how the OSI model works. The lower layers 1 to 4 usually define the infrastructure and the transport. The higher layers are all about the format and the meaning of the message. The layer 7 specifically is the application layer, and it is the highest layer where all of the semantics of the message go in. And this is where the 7 in HL7 comes from. HL7's objective is to set standards for the language that healthcare systems use for communication. A common language would make sure that the data has the same meaning across different systems. With this context, let's look at how we got from terminals to APIs. We'll take a look at this history through the stories of 3 people: Don Simborg, Abdul Malik Shakir, and Grahame Grieve. Along the way, we'll see what HL7 V2 and V3 got right and what they didn't, like what they got wrong, and how we finally reached where we are, FHIR. Don Simborg was the CIO at the University of California. Their hospital systems had a mainframe for billing and registration, and each department had custom mini computers. Each of these systems became its own silo, and data did not really travel between them. There were a few workarounds that people used. One option was that, again, the nurse went from terminal to terminal to access data in these different systems. Another option was that they had what they called like a front-end network, where a nurse could access data from multiple backend systems from the same terminal. Now, Don wanted to build something else, the first backend network, in contrast with what was already out there, which was the front-end solution. His idea was to set up a network that let messages be exchanged in a common format. In 1981, Don and his team ran the first application-level protocol that linked systems from different vendors at UCSF. It connected admission, discharge, and transfer, or as we know it today, ADT. It also talked about pharmacy and radiology. This protocol was called STATLAN, and Don created Simborg systems to commercialize this solution. In time, STATLAN was implemented in over 4 hospitals. Eventually, the board of Simborg systems decided to put the protocol in the public domain. It was necessary for a common language to exist publicly so that custom interfaces could survive against large players at that time. Along with this, they decided to organize a standards body to take this forward. The first meeting of this body was in Philadelphia on March 29th, 1987. One of the attendees remembers it as the worst thunderstorm that they've ever seen. Early STATLAN users, vendors, and academics were invited to this meeting. This body was named HL7, or Health Level 7, and they just decided this at the end of the day after the meeting. Their objective was to create a level 7, or like layer 7 messaging standard that was easy to implement and could be used immediately. These were the early days of HL7. They worked in small groups and iterated pretty quickly. And in a year, they had a working standard, V1. They released V2 in 1988. This was the first major version of the standard. And V2 also covered other more important things like billing, lab results, and both were important to convince hospitals to actually adopt it. And usually you don't really see V1 really being implemented because it was more experimental, whereas V2 was like, okay, this is it. This is something that can work. Now, STATLAN also added ideas from other protocols, like there was ASTM, there was the X12, and all of this, it brought in the good parts of these protocols. With the launch of HL7 V2, HL7 really invested in marketing. They would do live demos at AHA and HIMSS, And this was like in the 80s, so it was more or less the connectathons of those days. This got the community involved through like showing results, like that the interface was actually possible and it was so much cheaper than before. A HL7 interface again would cost about $10,000 in comparison to the existing solution that costed like hundreds of thousands of dollars. So it's like a 10x difference in how cheap it was. Critics started to say that HL7 is too influenced by Simborg systems. So Don stepped down as the chair in 1989. He still participated in HL7 behind the scenes. Now, by the mid 90s, HL7 was used in hospitals worldwide. And a big reason was how easy it was to use. Like V2 messages are super simple and they are delimited with pipes with each position having a fixed meaning. You might wonder why it couldn't just be key value pairs. Why did we need to know the meaning of a position? Now, this was because existing hospital systems were mostly programmed in COBOL, and they were designed to perform really well with structured, delimited data like this, like CSV or the HL7 message. It was all tabular, delimited data. They weren't very quick at like parsing these strings and the key value pairs that we know of today. The ease of use made HL7 really popular, but it also led to a lot of inconsistencies. Like HL7 V2 included a segment called the Z segment, which allowed people to share their own data, like in their own custom formats, even when it was not like formally defined according to HL7. So this meant that V2 could cover a lot of use cases, and that also meant that like V2 messages could be different from each other. So different working groups like started working on all of these segments independently, and there were a lot of inconsistencies across how HL7 V2 was implemented. There is a saying like if you've seen one implementation of HL7 V2, you have seen exactly one implementation of HL7 V2. So to solve these inconsistencies, the solution proposed was a shared information model. This idea had been discussed before by the IEEE medics group, again, like mostly academic, in the 1986 around this year, and a joint working group to actually work on this common data model was actually created. This included many vendors and standards organizations at the time. The core concept was to decide on a shared model first and then derive different artifacts for messaging from it. Now, HL7 adopted this idea and it became the reference model or the reference information model, the RIM. In 1996, Abdul Malik Shakir volunteered to work on the first version of the RIM. He put together data from many sources, like from medics, from other data models, from vendors and other standard organizations, including like V2, and even from what the insurance companies were using at that time. HL7 then iterated on these models in what they called harmonization meetings, where they could talk about what a common model needed to look like. The RIM grew in each meeting and soon became massive. It had 130 classes with over 980 different like attributes. It would take one person almost 3 days to lay out different connections in the reference information model. So people started asking if we can simplify this, and a much simplified, like a much more simplified RIM was the result of this proposal. It reduced many clinical classes into acts and entities by including a mood. Now, Abdul Malik here made the argument that the complexity isn't gone really, like it was just hidden in these simplified classes. But many were pretty happy with the results. A little side note before we move ahead, you can see that the working style for V2 and V3 were quite different. V2 did a lot more community outreach with their demos and early connectathons, but V3 was built by a committee, almost in isolation. Meanwhile, in New Hampshire, a small group of physicians and vendors met at the Kona mansion. Over a weekend, they created the Kona proposal, which was document first and used XML to package clinical information. XML was brand new at that time, and only a year after its first draft was released. This Kona proposal eventually was absorbed into HL7 and became CDA and CCDA. This is the clinical document architecture. These are the most widely used V3 artifacts and are even in use today. Between 2008 and 2011, many national programs, including the NHS, were trying to implement V3 and CDA. But implementing V3 was hard for people on the ground. The teams needed a cultural shift. They were used to working and counting pipes with V2. Now they needed to learn what this domain-driven modeling is, and it was just a completely new way of thinking. And the tooling wasn't there. People weren't used to XML, and for hospitals, the return on investment wasn't clear. They were already using V2 and they needed to keep supporting it, and V3 was not backwards compatible with V2. V3 also didn't gather the same support that V2 did through its community outreach and marketing. So the organic momentum was much lesser than V2. By 2011, HL7 decided it was time for a fresh look at things. So they launched the Fresh Look Task Force, and this had a simple objective: keep the good parts, make everything web-friendly, and learn from other industries. The first track that came out of this was CIMI, or the Clinical Information Modeling Initiative. It was led by Stan Huff, and it built heavily on openEHR archetypes. And yes, openEHR was already around by this time. So the idea was similar to V3, but openEHR was a little simpler, and archetypes were these maximal data sets. The second track was led by Grahame Grieve. He decided to ask a different question, what do implementers really want? He looked outside of healthcare for inspiration, and the HiRISE API by Basecamp really stood out. Grahame asked, what if healthcare could look like this? His plan was pretty simple, keep what worked in V3, the data types and the vocabulary, but deliver it in small, composable, web-friendly resources. Over the next few months, Grahame worked on this idea alongside his day job, and then he published it on his blog, Health Intersections, in August of 2011. It was titled Resources for Health, and he just asked feedback from implementers and the health IT community at large. The fall meeting of HL7 was only a few weeks after this. They saw Resources for Health and decided to work on it further. Now, Grahame was very particular that this standard needs to be in the public domain, which has not been the case for the previous versions. Both V2 and V3 could only be accessed through a license. And although you could access them freely today, back then, that wasn't the case. Once HL7 adopted it, marketing came up with a catchy name, like FHIR, or Fast Healthcare Interoperability Resources. They put together a core team, and they involved the community very early on with the first FHIR connectathon that happened immediately the next year. In 2014, they already released the DSTU1 version of FHIR, which was the first draft standard for trial use. So why did FHIR catch on when others didn't? So it kept the rigor of V3 with data types, value sets, and well-defined resources, and made interoperability feel familiar to the developers of that time, using popular tech available, using URLs with straightforward CRUD operations to actually modify resources. Another reason was the availability of profiles to adapt the base FHIR resource to their own needs. Unlike V2, where anybody could add a Z segment, profile creation had its own governance mechanisms. They handled extensions a little better. Despite all this, due to the rapid adoption, we are seeing a lot of profile proliferation. There is 10 different ways to represent the same thing. But we've come a long way towards real interoperability with FHIR. We started with data silos connected by 6-figure interfaces in the 80s. Don Simborg at UCSF set the foundation for showing that apps could talk at the level 7, and HL7 was born. With that initial lesson, they turned that into STATLAN, put that in the public domain. Then you had Abdul Malik Shakir then helping move from HL7 V2's scrappy Z segments into a more formal information model of the RIM. But again, it didn't really catch on, and people said it was too complex, and maybe it was a little ahead of its time, which finally brings us to today, where we have Grahame Grieve with FHIR. It took the rigor, but it also wrapped it in small web-friendly resources that a developer can easily use. And FHIR today is the language of the web for clinical data today. So I just want to tell you that it's never just a technology problem. It's also getting the people around it to use it. The tooling and just adoption in general requires people to use it in their real systems. So this is part of our free course on FHIR fundamentals. This is just an extra section in our course. So if you really want to check out FHIR and know the nuances of how to really work with FHIR, then do check it out. We have multiple sections going over in detail how you can actually make an API call, how you can set up your own FHIR server. So I will leave a link down below. Do check it out.